All right, section 2.4 is continuing with section 3. We're still solving multi-step equations, but these type of equations in this section are now going to have variables on both sides. So our steps are going to be the same, but after we combine like terms, we're going to add just something slight before we continue to add or subtract. So let's jump into our steps right away. So again, let's rewrite these. Distribute if possible. Reminder, it's not always possible. Not every problem has parentheses. Step 2 is to combine like terms. That has not changed. And then here's the difference here. We're going to use inverse operations to have only one variable. You're going to see that there are variables on both sides. So if we use inverse operations, we can then have just one variable. Add and subtract, and finally multiply and divide. Okay. In this section, we are going to run into some equations. They're like special equations. So we can have equations that are identities. And equations that are identities is when you solve, you're going to get the left-hand side equal to the right-hand side. So 2 examples, you could solve and get 5 equals 5 or 3 equals 3. When you have identities, that means any number you put in for the variable, it's going to work. You can put in 3 and your equation will solve out. One side will equal the other, or you can put in 2 and one side will equal the other. So then we'll call these when we're when we're solving the equations, we'll call them identities, but also know that, oops, that's not working very well. Let me try that. It's going to be an all, there we go, solutions. The next special type of equation that we have is equations that have no solutions. And when you're solving these, you're going to have one side that does not equal the other side. So you're going to solve and maybe one side equals 0 and the other side equals 1. Well, 0 does not equal 1, so that's not a possibility. Notice that looking at both of these types, the identities and the no solutions, there isn't a variable. Any other type of equation, when we solve, we still have that variable piece in our equation. These type of equations, you're going to lose your variable. And we'll do an example of that so that makes a little bit more sense here in a few minutes. So let's look at our first example. 5s plus 13 equals 2s plus 22. So following our steps again, first step, distribute. And if I'm looking, there are no parentheses. Next step is to combine like terms. If I'm looking on that left-hand side, I don't have like terms just on that one side. If I look on the right-hand side, there are no like terms to combine. However, that third step that we wrote in there, we do have 2 variables. We have 2 s's in there. So by using inverse operations, we can combine those so there's only one s. And my suggestion is always move the smaller number. That way, for the most part, it'll give you a positive variable. And I know we are more comfortable working with positive numbers than negative numbers. So I'm going to choose to subtract 2s from both sides. If you were to choose to subtract 5s, you'd still get the same answer. You just have an extra step in there. So when I do that, I now have 3s plus 13 equals 22. Still, I have one variable, so now I can move to adding or subtracting. I need to subtract 13 from both sides. I then have 3s equals 9. And finally, multiply or divide. I can divide both sides by 3. When I do so, s equals 3. We can always check our solution whenever we're solving equations. And start by just writing the original equation. And then rewrite it, plugging in that number that you just solved for your variable. So I plugged in 3 for both of my variables. And then just simplifying, on one side I have 15 plus 13, and the other side is 6 plus 22. And when I solve each of those, I get 28 equals 28. And again, if you get down to a statement that's true, where two numbers equal each other, then you have solved correctly. Our second example, 2 times the quantity 3x plus 1 equals 4 times the quantity x minus 5. So I do need to distribute, so I'm going to distribute my 2 and my 4. When I do that, I get 6x plus 2 equals 4x minus 20. And jumped ahead here. Combining like terms, notice on the left-hand side there's no like terms, and the right-hand side there's no like terms. However, I have two variables, so I need to subtract 4x from both sides, so I only have one variable. I now have 2x plus 2 equals negative 20. So adding or subtracting, I'm going to subtract 2 from both sides. That gives me 2x equals negative 20. Or, excuse me, 2x equals negative 22. And then finally dividing both sides by 2, I get x equals negative 11. Double checking my work real quick again, writing down the original equation. Then substituting negative 11 in for both of those variables. Working inside the parentheses first, following order of operations. If I keep going here, I get negative 64 equals negative 64. Solve the equation correctly. All right, last example. T plus 8 equals negative t plus 6 plus 2t. Okay. I don't have to distribute. Notice on the right-hand side, though, I do have like terms to combine. I have a negative t and a 2t. When I combine those, that gives me a positive t. So on the right-hand side, that's going to say t plus 6. Moving to the next step, I have two variables. I want to use inverse operations, so I only have one. So I'm going to subtract t from both sides. And notice when I do that, my t's cancel completely because t minus t is 0. And I'm left with 8 equals 6. While 8 does not equal 6, I no longer have a variable. I'm down to an equation statement that is not true. When that happens, this is a no solution. Okay. I did not leave an example of a type of problem that is an all solution, but it'd be similar to this one, except maybe it would say 8 equals 8 instead. Okay. Again, we're going to be spending 2 days on this section as well, and this is the only lecture that you will watch for section 2-4.